Hi everybody, today we're going to talk about transformations. There are different types of transformations. A transformation takes a point or a shape on a graph and it changes that point or shape. So we're going to talk about some different ways we can do that. The first one we're going to talk about is a translation. A translation is what we call a slide. So if the original figure is named triangle ABC, we name the new figure triangle A prime, B prime, C prime. These apostrophes after the letter we call prime. So let's take a look at a couple of translations. Triangle ABC is translated 1 unit left and 4 units up. Draw the image of triangle A prime, B prime, C prime. Identify the coordinates after the translation. So I'm going to start with point A, and it says 1 unit left and 4 units up. So from point A, I'm going to count 1 unit to the left and 4 units up. And that's going to be where I put my new point, A prime. That ordered pair is at 0, 1, so I can fill that in over here. Then we start at B and we do the exact same thing. 1 unit left and 4 units up. There's my new point, B prime, at 2, 4. And again, we do the same thing at C. 1 unit left and 4 units up. So here is my new point, C prime, at 3, 2. I can connect these lines, and you see we have the exact same triangle shape. It just slid across the graph. So we see here, it's a general rule. This translation could be written as X, Y, and then our arrow, X blank, Y blank. So we're going to fill in these blanks. Let's take a look at these. When we went 1 unit left, we went back 1 along the x-axis. So our x value decreased by 1. So we are going to subtract 1. If we look at that, 1 minus 1 is 0. So that works here. Let's try here. For 4 units up, we are going up 1, 2, 3, 4 on the y-axis. So our y is getting bigger by 4. So we're going to add 4. Negative 3 plus 4 is 1. So that works. If we look at our point B, 3 minus 1 is 2. 0 plus 4 is 4. That worked. And C, 4 minus 1 is 3. Negative 2 plus 4 is 2. So based on the direction we're going along the x or the y axis, we know if we're going down, as in left, smaller, down, smaller for y, up, bigger for y, right, bigger for x. So our rule here could be written as x minus 1 and y plus 4. Typically, we won't be asked to write these rules, but we could be given a rule. Let's try one of these. Point A, negative 2, 4, is translated according to the rule x, y, arrow. We have x plus 2, y minus 3. What are the coordinates of A prime? So I have my rule, and I have point A. So what I can do is I can take point A and plug it in for x and y. Negative 2 is x, 4 is y. So when I plug this in, all I have to do is simplify these, and I have my new ordered pair. So negative 2 plus 2 is 0. 4 minus 3 is 1. So point A prime is 0, 1. So when we are given the rule, we have a little bit of a shortcut where we can just simply put the point in for x and for y and simplify. Our next type of transformation we're going to talk about is a reflection. And if you think about a reflection, like looking in the mirror, it flips everything. So a reflection is a flip. And if we see here, we've got an arrow here. And if we folded this paper in half across that x-axis, then these arrows would be touching. So again, it's almost like a mirror image. If you were to fold that, it would be like looking in a mirror for that arrow. So this one, because it's flipped over the x-axis, That's also called y equals 0. So this is a reflection over the line, y equals 0, or the x-axis. So when we reflect across y equals 0, we have our point, -3, -5. So we want to find w prime. So what we do is we draw our line. So we're reflecting over the x-axis, or the line y equals 0. That's where we draw our line. Then we are going to count to the line from point W. 1, 2, 3, 4, 5. Then I'm going to count the same number of units on the other side of the line. 1, 2, 3, 4, 5. That's going to be where I'm going to put point W prime. And that ordered pair is at -3, 5. Let's try another one. This one here, if you look, this is reflected across, looks like the y-axis. Remember, our reflection is a flip. So this shape flipped across that y-axis. And the y-axis is also known as x equals 0 for the line equation. So this is a reflection over the line x equals 0, or the y-axis. For our example, we're going to reflect across that line x equals 0 for point W. W starts out at 3, 5. We have the exact same process. We're going to draw the line. So we're reflecting over the x equals 0 line, or y-axis. That's where we draw our line. Our second step, still the same. We count to the line. 1, 2, 3. Third step, count the same number of units on the other side of the line. 1, 2, 3. And that's where we put point W prime, which is at -3, 5. We have one more reflection to talk about. This one, we have a diagonal line going straight across from one corner to the other corner of the graph. Remember, a reflection is a flip. So this triangle here flipped across that line. This is a reflection over the line y equals x, which is a diagonal line. So let's try this. Our steps are still the same. We draw the line. So corner to corner on my graph here, y equals x. I'm going to count to the line. It doesn't matter which direction I count. I can go down or I can go to the right, as long as I'm going across the grid lines and not diagonally. So we count 1, 2, 3, 4, 5, 6. Okay, so here's where we change it up just a little bit. We count the same number of units on the other side, but I can't count straight down. I have to change direction here. So I'm going to count, changing direction. So I went down, so this time I'm going to go right. And if I counted right first, I would have gone down then. So we change direction, and then we count again. 1, 2, 3, 4, 5, 6. And that's where I put my point, W prime, which is at 2, -4. Now, let's take a look here. You see our original point is -4, 2. Our new point is 2, -4. We have the same number, but they're reversed. They're flipped. So we do have a shortcut for these. If it is reflected over the line y equals x, then y literally equals x. So we take our x value here, and that's our new y, and vice versa. Our y value becomes x. So our shortcut is, if we have xy, and it's reflected over the line y equals x, then we just flip places, and it becomes yx. The next transformation we'll talk about is a rotation. A rotation is a turn. So a clockwise rotation, 90 degrees, would be one turn about the origin. For an example, reflect point W, 90 degrees clockwise about the origin. So we can actually hold up our laptop, turn your laptop once clockwise, and identify the new coordinates. If this is a little tough, feel free to take your phone, snap a picture of the graph, and then turn your phone to be able to see that picture turned. So here, we're going to take this graph, And by the magic of PowerPoint, I'm going to turn this one turn. Ta-da! And we have a new point at here. If I count backwards, I have to ignore these marks on the graph. So I'm going to count back 1, 2, 3, 4, 5, up 1, 2, 3. So -5, 3 would be that new point. Now, a rotation, remember, is a turn. A clockwise rotation, 180 degrees about the origin, is going to be 2 turns. So for our example, reflects point W 180 degrees clockwise about the origin. So again, you can turn your laptop, or you can take a picture with your phone and turn your phone to be able to see that picture in its rotation. So turn it twice clockwise. Once, twice, and now I identify the new coordinates. Again, ignoring these numbers on the line because they've changed. And I just count from the origin. 1, 2, 3, up, 1, 2, 3, 4, 5. This is my new point, W prime. So it is 3, 5. One more rotation to talk about. 270 degrees. Rotation is a turn. 270 degrees is 3 turns about the origin. So to reflect point W 3 times, 270 degrees clockwise, we turn it 3 times. You can hold up your laptop or use your phone and snap a picture and turn your phone 3 times. And then we'll identify the new coordinates. So once, twice, 3 turns. And my new point, counting from the origin, 1, 2, 3, 4, 5, down 1, 2, 3. That's 5, -3. That's my new point, W prime. All right, one more transformation to talk about. Dilations. A dilation is a change that enlarges or reduces a figure. Otherwise, a change in size. It can make it bigger, or it can make it smaller. So here it tells us to graph the image of triangle TUV after a dilation with a scale factor of 2 centered at the origin. Now, when it says scale factor, that means we multiply. So it says identify the coordinates after the dilation. So we're going to take each of these points and we're going to multiply them by the scale factor. So I'm going to take point T and multiply both numbers by 2. Same thing for point U and point V. So for T, I'm going to take 2 times -3 and 2 times 1. So I'm multiplying both numbers in the ordered pair. And then I simplify. So when I multiply each of these numbers, that becomes -6, 2. I'm going to plot my new point, -6, 2, over here on my graph. And that point becomes T prime. Move on to U prime. We have 2 times U times U. So 2 times 5 and 2 times 1. I simplify that, it becomes 10 and 2. So at 10 and 2, I put another point, U prime. 2 times V, so 2 times -2 and 2 times 4. I write those out, simplify. 2 times -2 is -4. 2 times 4 is 8. So that's my new point, V prime. So at -4, 8, I put a point here for V prime. And then I can connect my lines, T to U, to V, back to T. And you see it's the same triangle shape, it's just bigger. Let's try another one. Graph the image of triangle TUV after a dilation with a scale factor of 1/3 centered at the origin. Scale factor again means multiply. So I'm going to multiply each of these coordinates by 1/3. So I'll multiply T by 1/3 and point U and point V. So I'm going to take this 1/3 and multiply it with both numbers in the ordered pair. And then I'm going to simplify. 1/3 times 9 is 3. 1/3 times -9 is -3. So 3, -3 is my new point T. 3, -3, I'll put a new point there and label it T prime. Next, 1/3 times point U. So 1/3 times 9 and 1/3 times 9. Simplified is 3, 3. So at 3, 3, I'll put a point and label it U prime. Last one, 1/3 times point V. -9, -9. So 1/3 times both of these numbers, which is -3, -3. And here, we put at -3, -3, point V, or point V prime, excuse me. And then I connect my lines. So T to U to V, back to T. We see we have the same triangle, just smaller. All right, guys, let's practice a little bit.